Applications of integration, finding volume using the shell method. Revolving a region about the y-axis produces a solid. If we want to know the volume of the solid, we could write everything in terms of y and use the washer method. But there is another method to finding the volume that allows us to keep everything written in terms of x. This method is called the shell method. If we revolve this rectangle of width dx about the y-axis, we get a cylindrical shell. The cylindrical shell will have radius of x. It'll have height f of x and thickness dx. Slicing the shell and opening it up, we get a sheet. To find the volume of the shell, what we do is we ask ourselves, what's the volume of this sheet? Well, a volume of a sheet is just its length times its height times its thickness. So what's the length of this sheet? Well, the length of the sheet is just the circumference of the shell, of the cylindrical shell. And circumference is 2 pi times the radius. Next, remind yourself, what is radius? What is the height of the shell? And what's the thickness of the shell? Once you do that, you have found the volume of the shell. So to recap, the volume of the shell is the circumference, 2 pi x, times the height, f of x, times the thickness, dx. Adding up all the shells, we get the volume of the solid. For the more general case, the height is just your upper function minus your lower function. Let's do an example. Let R be the region bounded by the graph of f, the x-axis, and a vertical line x equals square root of pi over 2. Use the shell method to find the volume of the solid generated when R is revolved about the y-axis. First, determine the region R. Once you've done that, you need to set up your integral. Well, we have 2 pi x. That's a given. Your function is sine of x squared. And then x, your interval of integration, is x running from 0 to square root of pi over 2. To integrate, we need to use substitution. Let u equal x squared. In that case, what's the derivative of x squared? That's just 2x. So du is 2x dx. If x equals 0, u would have to be 0, because 0 squared is 0. Now, if x equals the square root of pi over 2, what's the square of that? U would have to be pi over 2. So make your substitutions. Before you make your substitution, you might want to rearrange things to make that substitution a little bit easier. Notice I pull out the pi. I also moved the 2 and the x so that it's right next to the dx. And I did that because I saw that du will be 2x dx. So I just moved that 2 and the x right next to the dx. It makes the substitution a little easier. So make your substitutions, and this is what you get. Next, integrate. After you integrate, you need to evaluate. Now, cosine of pi over 2 is 0. Cosine of 0 equals 1. And when the dust settles, you get pi cubic units. And that's the volume of the solid. Now, if you were to use the shell method about the y-axis, this is the formula that you would use, and we saw how this formula is generated. If you revolve about the x-axis, and if for some reason you want to use the shell method, you would use this formula, and it's found in a very similar manner. Now, here's my general rule. If you're revolving about the x-axis, I recommend that if you can, use the disk or the washer method. If you're revolving about the y-axis, if you can, use the shell method. Now, if you follow this rule, then this will keep everything in terms of x. So you don't have to rewrite, have x and y change, their roles and stuff. It's much easier if you just keep everything in terms of x. Now, there are exceptions. Sometimes the actual integration is easier if you use a method that results in putting everything in terms of y. But if you are given a choice, I recommend Linda's general rule. Revolving about the x-axis, use disk or washer. Revolving about the y-axis, use the shell method. And if you do that, your life will be easier because you'll be keeping everything in terms of x. Take care and have a great day.